Okay, number 16 is kind of testing your ability to read a wordy problem here and do a lot of translating on your own here. So a road is perpendicular to a highway. So what's talking on? This is the highway right here on the bottom, guys, and then this is the road they're discussing here. Gotcha. Perpendicular to the highway, so we know we're dealing with a right triangle here. And the farmhouse is located 2 kilometers away from the road. So that's what's going on here, 2 kilometers on the left. Now, of course, it's hopefully obvious, the farmhouse isn't moving and neither is the road, so this amount right over here on the left is fixed. We do not need to put a variable in for that distance right there. An automobile travels past the farmhouse at a speed of 80 kilometers per hour. Gotcha. They want to know how fast is the distance between the automobile and the farmhouse increasing when the vehicle's 6 kilometers past the intersection of the highway and the road. Okay, this can get a little bit confusing here because the wording is difficult. This quantity down here on the bottom of the triangle here, I'm going to go ahead and call that x. Now that needs a variable there because as the car travels down the highway, x is changing in how far the car is from where the driveway or where the road meets the highway. Now, beyond that, D, which I'm going to call this right here, is representing the absolute distance between the automobile and the farmhouse, and that's growing as well. So the derivative that we were given in this problem right here is that 80 kilometers per hour. That is how quickly x down here on the bottom is growing. So the derivative of x with respect to t is 80 kilometers per hour. And think real quick, should it be positive or negative? Since the automobile is now moving away from the farmhouse, x is growing, its derivative should be positive. And the derivative we want to know, how fast is the distance between the automobile and the farmhouse? Here's the auto, here's the farmhouse. We want the derivative of d, distance, taken with respect to time at the moment when the automobile is 6 kilometers past the intersection of the highway and the road. Here's the intersection of the highway and the road. That's the amount then that's going to be 6, so that's going to be x. So we want x to be 6 kilometers. Okay, and that's what we're looking for. So we need an equation that relates x and d. That's going to be the Pythagorean theorem here. X squared plus, now again, this leg is fixed. It doesn't change in the course of this problem. So we can go ahead and square the 2 there to get a 4, and that equals our hypotenuse squared, and there you go. Remember, guys, one more time, that 2 is fixed. It is not a time-specific value. So it's okay to go ahead and use that before we have differentiated here, and we shouldn't get in any trouble that way. All right, now let's go ahead and let's differentiate this with respect to time. Derivative of x squared is going to be a 2x dx dt. This would be a plus 0 there from the plus 4, so I'm not even going to bother writing that, is equal to a 2d and then a dd dt. All right, 4 variable quantities. We better know the values of 3 of them. So 2 times, and right here, x is going to be 6 kilometers at that moment, and then dx dt was given to us right there as 80 kilometers per hour. That's going to equal 2 times a d value that we don't know right yet. Let's deal with that in a second. And then the dd dt at the end of that we're not supposed to know because that's what we're trying to find. So the missing link here, guys, is how big is d at this moment in question. So let me switch to red here real quick, and my time-specific value for this problem, let's take a look, would be a 2 kilometer distance over here on the left. That hasn't changed, but the time-specific value for x would be 6, and we're looking for d here. So we'd get a d squared is equal to a 2 squared plus 6 squared using the Pythagorean theorem. D squared would be what? 4 and 36. That would be 40. So d would equal the square root of 40, which I could simplify into a 2 root 10, but honestly, let me just leave it that way for now. So the square root of 40 is how long d is at that moment in question. And now, guys, let's see if we can't just polish this off real quick. Let's see, 2 times 6 is 12. 12 times 8 is 96, so that left side is going to be 960. And let me leave this Yeah, sure, why not? I'll leave that as a 2 root 40 and then a dt. So to solve that, we're just doing some division now. Dt is equal to a 960 divided by 2 root 40. So let me go to my calculator and type that in. I'm not sure where I am here. All right, and let's add a calculator page. And here we go. So we said 960 over, and now I forgot like I knew I would, 960 over 2 root 40. Gotcha. So we've got a 2 times the square root of 40. And on your calculator, guys, I'd go ahead and hit Control Enter. Let's get that answer as a decimal here. 75.895 would be our answer here, guys. So 75.895. And our rates here were being measured in kilometers per hour, so that's where we ended up. So the question I guess I have for you guys is, if the car is moving down the road at 80 kilometers per hour, does it make sense that this distance here is growing at a speed just a little bit less than that? Yeah, hopefully that does make a little bit of sense and seem realistic to you guys. So, okay, that's our answer then for problem number 16.